So welcome to academic guidance class. You can see in this video they asked us in the question that we should find the currents flowing through the 10 ohm resistor using Thevenin theorem. So in order to do that, this 10 ohm resistor has to be put in an open circuit. So when I say open circuit, it's more like saying cut the wire, so no current will flow through that loop. The whole of, when I say loop, it means like that box you are seeing. So no current will flow there. So that's what I'm doing there. So that's what we have here. So you see, we've opened it. It's different from short circuit. Assuming I say short circuit, it will be like making it to become just wire without a source. So we've opened it. So we have the VTH now. So VTH, to find the VTH, is more like standing there where I put VTH, standing there, looking inside that particular loop, that particular box. Notice you won't find any current flowing again, but you see the 5 ohm resistor and the 8 ohm resistor. So in order to find the VTH, we have to go and find the currents flowing in the first loop and the one flowing in the third loop. So the currents flowing in the third loop will be entering the battery from the positive terminal, so and leaving through the negative terminal. And when it has to do with Thevenin theorem, you need to know that in Thevenin, you always take it that the same current flows on a particular loop. So there will be no current in this loop, in the second loop, that place of VTH. But in this first loop, you see that the same current will flow, entering from the positive, leaving from the negative. So the same current will be flowing out. While on the third loop here, current entering through the positive, leaving through the negative, the same current I2 will flow around. So from positive, the bigger part of the battery going around. So that's what the current we have. So let's now find the current in the first loop. So current in the first loop will be equals to the voltage.
Before I do it this way, let's do it this way, sorry, so that we don't make mistake. I could have said, let's find out the I. This I is here. It's also going to be here because it's the same current. So in this case, this I2 is here. It's also going to be here, the same current. So all I need to do is to simply say, let's find out all the current. So I have 5I1, then plus 15I1, all the currents equals to 20 volts. So another way to do it is to simply start from this. You say the 20 voltage, if it's going this way, minus the 15, because it's leaving this way, it's entering from here. So you can say moving from this way, it's supposed to be negative 20V. Then as it's moving this way from this outside, that means this one will turn to positive. Or if you're having to make it positive, starting from positive, you now have that this is going to be the 20 becomes positive, minus 5I1 minus 15I1 equals to 0. Whichever way you want to do it. But for the fact that we've learned this properly using nodal analysis, I want us to always focus on it like this. The whole current equals to the voltage. Or you say, yes, you can just say, since you are summing up the whole current inside here, then minus the voltage, because the voltage is leaving through the negative part. So minus 20V equals to 0. Now by the time you next your formula, this becomes 20I1 equals to 20V. So I1 is equals to 20 over 20, which is equals to 1 amps. So this I1, the I1 here is is equals to 1 ampere. Now for this I2, this is how to go about Thevenin. For Thevenin, you use loop analysis. You assume the same current flows inside loop because it can't continue. So you come to this one for the I2. I'll do the same thing. I2, I'll say I have the current entering. This current will be I2. Then it's leaving through the negative side, so it's minus 10 volts. Then another current plus 8I2 equals to 0. So it's more like saying summing up all the currents since they are the same, summing it up, then subtracting the voltage because it's leaving through the negative terminal. It means negative. I told you when we did Kirchhoff that once current passes through the negative part of the battery, the terminal of the battery, there is negative voltage. So when you do it, you see that this plus this is 10 I2 equals to this equals to 7 equals what? So that's 10 positive. This equals I2 equals to 10 over 10, which means that this is also 1 amps. So the I2 here is equals to 1 amps as well. So we've been able to get that. So remember what we're doing is using Thevenin theorem, not Newton's. Assuming it's Newton's, there will be no open circuit, it will be wire all through. So that's where we now do all those our direction and all those things. Yeah. Now, when you get to this, you now come and say, now that you have the current, the whole current here, I1 is equals to 1 amps. The whole current here, I2 is equals to 1 amps. So to get Thevenin now, is simply going to say, if we have this to be VTH, I can choose to go this side or I can choose to go this side. But since this voltage is higher than this one, it's more like when you have something like this and you have something like this. It's easy for, if you place a current here, let's say current here is a ball. If you place a ball here, the ball will quickly roll down this way. So that means I want to take it the direction I'm going is this way, because the voltage on this side is higher. So standing here and looking at this, I'm going to be seeing only the 8 ohm resistor and 15 ohm resistor. So all I will do here is to say VTH and going this way now. Once, remember when I taught you Kirchhoff, I said that if you're pointing voltage, you always say if voltage is the positive, what you're starting with, all the currents there, you're going to be doing subtracting, or you simply say equals to. Remember that V from Ohm's law is equals to IR. So if you don't want to do it like that, you can just say Ohm's law, voltage is equals to IR, and IR means voltage as well. So this is going to be 8 here, and the 8 is connected to I2. The currents that this 8 ohm resistor is experiencing is 8I2. So then plus, that is RI, which is IR. So plus this 15 is coming here, 15. Then the current it will be experiencing is 1. So I1. So this is the same as that V minus R, this minus, which will be equals to 0, is the same thing, because if you put this now, it becomes minus all equals to 0. What I mean is this. This is the same thing with this, because when it crosses equality sign, it becomes this. So notice that. So now see, this is going to be VTH is equals to 8. I2 is 1 plus 15. I1 is 1. So when you times it, you see that your VTH is going to be 8. Yes, wait. What are you doing? What are you doing? Okay, yes. See, thank God we corrected this. See, at this point, notice that the arrow on this 15 is this way. That is, your I1 on this. Your I1 on this 15 is going this way, right? Yes. While your I2 on this is going this way. Let's check it out. Coming this way. coming this way. Yes. Okay. What am I doing? Yes. So see, so we don't make mistake because we almost missed it. Let's do this properly. Let's analyze this here. The I on this 8, the I2 here is this way. This is the I2. So the I2 on the 8 is like 8 I2 like this. While on this 15, yes, actually. While on this 15, is it the same thing? ID. So I have this moving here up to this, and this moving here up to this. So that by the time this one come here, it meets this, and then so VTH. So see, I have 8I2 like this on this. Then I have 15I1 like this. But notice something. This VTH that is coming here, this VTH that is coming here is coming down on 8 this way. It's coming down on the 8 like this. While the VTH is coming up on the I1 like this. So see, on their different loops, they are having the same direction. But the VTH itself that I chose is what will determine. So when this VTH is coming down, it is going to be meeting 8 like this. It's meeting 8 like in opposite direction. It's meeting the 8 in opposite direction. So you see that because the direction is going is different from these 8. That place that I'm supposed to have VTH, that time we started that we normally do VTH now as it's going minus, it's supposed to be minus 8, but because this 8, the current here is in opposite direction to it will now be plus 8I2. So you see, we wanted to do everything to be equals to, but sometimes it will make you enter mistake or make an error because the direction is important. So see, it is going in opposite direction to this because we chose this side. If you chose this side, it will still happen. So to the other one, so it's going this way while this one is going this way. Now when it comes here as it's going, you will see that this particular current on I1 is in the same direction with it now. So it will be minus 15I1 equals to 0. So please, what this thing teaches us is that when it's Thevenin, let's maintain this approach of using the voltage plus minus and whatever till we get to equals to, then we now do collecting line terms, because if we try to do voltage according to Ohm's equals to this, we might forget the direction of the current. So that is what it helps us point out. So now that we've gotten this, we'll now come and say VTH will now be equals to, if this is crossing equality sign now, it will now be equals to minus 8 plus 15. Then this is I1, this is I2. So that this becomes minus 8(1) plus 15(1). So this is going to be 15 minus 8. That should be 7. So that is going to be 7 volts. So please, we are not wrong. So see, let's say I do this like this now. You agree that current moved here on this one, and this is 8 ohms. And then we also agreed that current moved here, and this is 15 ohm. So if that is the case, notice that if we are talking about this VTH Thevenin, we always stay at a place and look at everything. You see that as it's coming here, the current, it will meet here. is in this direction while it is going this way, and as it comes here, the current it will meet here is in the same direction. So note that. So it's the same thing as saying VTH equals to meet an opposite current, negative, and then meet current in the same direction, positive. So you've noted that. Now that you've gotten your VTH, we need to get your VTH. The next thing to do is to remember that the question that we started with asked us to find the current in that 10 ohm resistor, not just VTH. So we remember that Thevenin, his theorem stated that in a linear circuit or multi-complex circuit, linear circuit, that the voltage, the Thevenin voltage and the load resistance and Thevenin resistance are always in series. So if I know that, let's put this in series. So I will now have so however you want to draw your own. So this is that Thevenin voltage, 7V, VTH. This is, let's say this is our load resistance, which is equals to 10 ohms. Then our Thevenin RTH, we've not gotten it. So to get our RTH, all we need to do is to now say, since we're done with this, to get our RTH, all we need, remember that I1 is 1 amps, I2 is 1 amps, VTH is 7 volts, load resistance is 10 ohms. So all we need to do when we are doing this is to simply say, now it's going to be RTH we are finding from this point. So to find RTH, Thevenin resistance, short circuits this. So turn everything that is an external voltage, that is giving voltage, assuming I have maybe ampere here, everything that is a given current as well, short circuit it. So make it a wire. When I say short circuit, it means make it a wire while the resistance remains. If I say open circuit, it means cut the wire. So this is going to be the 15 ohm. The 15 ohm. This is going to be the 8 ohm. Yeah. So if I know this, so this one remains. So if I've noted this, this is how you do resistance. It's either you draw the resistor like this or you draw it like this. So if I've noted this, all I'll do now is to simply just stay recording. Okay, so if I do like this, to get the RTH now, I'll simply say, notice that everything here is in parallel to this, is parallel to this, and everything is parallel to this. So it's the same thing as saying, see now, if I have this coming here, current will enter here and also continue. So once your current cannot be just straight and continue, you see junction. How to know parallel is to see junction. This current will come, drop here, and then continue. So it's parallel. Assuming it continued, so I will say 5 times 15 all over 5 plus 15 is in series with 2 times 8 all over 2 plus 8, because these two are in parallel as well. So this is going to be 5 times 15 is 75 over 20 plus 16 over 10. And this is going to give me 75 divided by 20 is 3.75. 3.75 plus 1.6. So plus 1.6, which is equals to 5.35 ohms. So RTH is 5.35 ohms. So now that we've noted that, remember the question asked us to find current in the 10 ohm resistor. So to find the current, since they are in series, all I need to do is to simply say, from Ohm's law, V equals to IR. I is equals to V over R. And notice that the R here is simply going to be, the R here is going to be the total resistance in this. So it's going to be 10, yes, wait. In series, what are you doing? The current in series. If I do plus this, okay, if I do plus this, it's going to give me the total resistance here. I'm coming. So let me find the total resistance first. I do 10 plus 5.35 all over. If they are in series, their voltages are not the same. So note that. So I will now have over 7. So this is going to be the sentence saying the total current, the current in series, current for anything in series is the same, but voltage is not the same. So let's do this. This will be 7. This is 15.35. 7 divided by 10.35. So this is going to be 7 divided by 15.35 is going to be 0.45 or 0.46. So this is the total current, or we say Thevenin current. This is Thevenin current, the total current. So if I want to find the current in this, the current in this one, all I need to do is to simply do, yes, okay, yes. So if I want to find the current in this, the current here will be the same current here. The current here will be the same current here, which is this current, because current for series is the same. So the current here is the same thing here. So that means that the current in I, the load resistance, is equals to the current in the Thevenin resistance, which is equals to 0.46 ampere. So note that, and you know that anything series is adding up. So there you have it. So it's almost as though when it has to do with Thevenin voltage and Thevenin theorem, it's simpler. Just find, then that is find the current here, then standing here, you look at this, whatever thing you can get to find your Thevenin voltage. Thanks, subscribe.